Hi, this is Mrs. Vrobel. This is Chapter 13, Part 1 for gases. We're going to be talking about a number of things today. The first thing we'll be talking about is the Avogadro's principle. And notice that we're talking about how do the number of particles relate to the volume. Then we're going to look at the relationship between pressure, temperature, volume using Boyle's law and Charles' law. And then lastly, we'll apply those laws. Now, this is a little bit of a review. We've talked about the units of pressure. You're going to need to know how to convert between the different units. Notice that 760 millimeters of mercury is the same as 1 atmosphere, which is the same as 101.3 kilopascals, which also relates to the English measurement 14.69. Okay, so we're going to take the idea of gas laws and we'll actually apply it to everyday life. How I think of it this way is when you're breathing, you're actually using gas laws. So when you inhale, think about what's happening to your lungs when you do the inhalation of air. And then when you exhale, what's happening to your lungs there. So we're going to apply that eventually to gas laws. Now, like I said, we're going to talk about Avogadro. Then we're going to discuss Boyle's law and Charles' law in this video. In the next video, I'll talk about Gay-Lussac's law and the combined gas law. And then lastly, we'll look at the ideal gas law. I'll briefly mention Dalton and Graham's law. That's a bit of a review. Okay, so in Avogadro's hypothesis, there's a picture here which shows us with a certain amount of moles, we have a specific amount of volume. And notice the pressure stays the same. When you increase the amount of moles, notice that the volume increases by that increased number of particles. And then lastly, if you triple it, notice that you have a tripling of the volume. So what this means is that if you have same temperature, same pressure, whatever the volume is, notice that it's going to equilibrate with the number of molecules. So the more molecules you have, the more volume you're going to have. Okay, this graph actually is from the lab that you have done already. And my question is, what is the slope? And the slope actually explains the relationship between the two variables. So we have pressure and volume. So when you have high pressure, what happens to the volume? And when you have low pressure, what happens to the volume? So think about when you're breathing, when you're inhaling, what are you doing to the volume? And as a result, something should happen with the pressure. And then when you exhale, you're doing something to the volume. So as a result, there should be a change in the pressure. So with Boyle's law, please note that pressure is inversely proportional. This is really important. We're going to be focusing a lot on the relationship between the variables. So pressure is inversely proportional to volume if you keep temperature and the amount of gas the same. And from your lab, you probably noticed that we multiplied the two together to get some constant. And as a result, we use this formula here, P1 times V1 equals P2 times V2. And we'll use that a lot. Okay, so very first problem here. Here we have 4.5 liters and 2.5 atmospheres. So I'm going to multiply them together. So 2.5 ATM times 4.5 liters. Please use units, that's really important. And that equals some pressure, we don't know what that is right now, times 5 liters. So I'm going to rearrange it so that I have P2 by itself on one side. And when I do that, I'm going to take 2.5 ATMs and I'm going to multiply it by 4.5 liters and then divide by 5 liters. When I do that, I come up with some kind of pressure because the liters cancel out. And I got 2.25 atmospheres. Now I want you to do this second problem here, and we're going to go through it in class. So make sure you practice this on your own, and then we'll go over it in class. Okay, here's another relationship, and this one we hopefully will practice it in the lab. But my question is, what is the relationship with the two variables? And by looking at the slope, that can actually tell us the relationship between the volume and the temperature. So notice if you have a low volume, what happens to temperature? If you have a high volume, what happens to temperature? Okay, with Charles' law. So this scientist had found that when you start at 0 Celsius and you have the same pressure, as you increase the pressure, what happens to the volume? So he noticed that there was an increase. And as a result of that, he discovered that it was directly proportional. So volume is directly proportional to temperature, and that's really important with this law. And we can use this relationship, V1 over V2 equals T1 over T2. Okay, so here I have a problem where I say a volume of gas is 44.3 milliliters. Now, when you're doing this kind of problem, you don't have to change it to liters yet. Eventually, we will have to, but for now, we're just going to keep it in milliliters. And I'm going to divide it by the temperature. Now, it's 25 Celsius. I have to change it to Kelvin, so I add 273. Notice that becomes 298. And then I'm going to use the second volume, I don't know what that is, on the other side. And I'm going to add 100 to 273 to give me 373. I'm going to rewrite this with V2 by itself on the side. And notice it's 44.3 milliliters. And I'm going to multiply it by 373 because I cross multiplied, divided by the 298. And when I solve for that, I got 55.4 milliliters. Okay, I want you to do the second problem. By the way, standard state temperature, we're talking about 0 Celsius. So 0 Celsius would be what in Kelvin? You got to remember that. So do number 2 and we'll go over it in class. Okay, so please note with Avogadro's principle, we say that equal volumes of gases at the same temperature and pressure should contain equal number of particles. And this doesn't matter for what type of gas it is, it just matters that the temperature and pressure is the same. Please note with Boyle's law, we're talking about an inversely proportional relationship between volume and pressure, okay? So if you increase one, the other should decrease. Whereas Charles' law, if we have a fixed amount of gas, it's directly proportional to the temperature. So if you increase one, you're going to increase the other.